Hello everyone. In this video, we will discuss on normal distribution. So we'll discuss about what is normal distribution, why it is used, real life examples of normal distribution, and how mean and standard deviations are used in normal distributions, and what is meant by 1, 2, 3 standard deviations from the mean. And also we'll see example like calculating and visualizing normal distribution and z-score calculation per normal distribution. So a normal distribution is a type of continuous probability distribution for a real valued random variable. So the graph of a normal distribution is bell-shaped and symmetrical, and it is centered around the mean. So in a normal distribution, mean determines the center of the distribution, whereas standard deviation determines the spread or width of the distribution. So why normal distribution is used? The normal distribution is widely used in statistics because many natural phenomenon measurement outcomes tends to be normally distributed. So it helps to make inferences about populations from sample data and making it crucial for hypothetical testing, confidence intervals, and many other statistical analysis. So if you see the real life examples of normal distribution, like height of the people, okay? So heights in a population tends to follow a normal distribution where most people fall near the average height and a fewer people are either much shorter or much taller. So and similarly, IQ scores. So IQ scores are designed to be normally distributed with a mean of 100 and a standard deviation of 15. And one more example, like measurement errors. Measurement errors in experiments often follow a normal distribution. Okay. And so mean, the average value around which the data is centered. Whereas standard deviation, it's a measure of how spread out the data is. So it quantifies the dispersion of the data set. Okay. So now, so let us see what is meant by one standard deviation, two standard deviation, and three standard deviations. So one standard deviation means roughly 68% of the data falls within one standard deviation of the mean. And two standard deviation means about 95% of the data falls within two standard deviations. Whereas three standard deviation means approximately 99.7% of the data falls within the three standard deviations. Okay. So this is often referred to as 68, 95, 99.7 rule. Okay. Let us see with one example. First, let's work on the Python example 1, calculating and visualizing normal distribution. Okay, so here let us import numpy as np and import matplotlib pyplot as plt and import scipy.stats as stats. So now after importing all the libraries, then we have to generate some data that follows a normal distribution, right? So let us generate some data that follows a normal distribution. So let us take mean as 50 and standard deviation as let's say 10 and data equals to numpy we have considered as np dot random dot normal, and we have to pass the mean, standard deviation, okay. So now we have to plot the histogram. of the data. So PLT dot. So PLT is nothing but matplotlib pyplot. Okay, PLT dot histogram hist, and we have to pass that data, and we have to set the bins, and density is true. Alpha we have to set to, let's say, 0.6, and then color, let's say G. Okay, so once we plot the histogram of the data, then we have to plot the normal distribution curve. Okay, now we'll take the minimum and the maximum. Plot dot x lim. Now x is equals to n dot np dot line space. We have to pass x minimum and x maximum 100. P equals to stats dot norm dot pdf x mean, and we have to pass the standard deviation. So now we have to plot the graph. We have to pass the variable that x to draw the normal distribution curve, and then value of p, and k and line width equals to 2. So let us keep the title normal distribution. Let's say mean 50 and deviation 10. And then plot dot show. Okay. So in this example, what we have done, the data is generated using a normal distribution with a mean of 50 and standard deviation of 10. And we have a histogram is plotted to show the distribution of data. Okay, the normal distribution curve is actually, it is overlaid. So let us run this code and see what happens. So if you see here, so mean is 50, and then the standard deviation is 10. Okay, if you see this, it's around the curve, normal curve formed at the mean 50. Okay, this is this kind of similar graphs called as normal distribution. And we will quickly see the second example, calculating the G-scores. So generally a G-score tells how many standard deviations an element is from the mean. Okay, so for this what we'll do, let us take data with heights of people in centimeters, and we will put it in the list. So 160, let's say 165, 170, 155, 75, 180, 185, 160, 162, 167. So like this, I'm taking data. Now what I have to do, I have to calculate the mean and the standard deviation. So mean height equals to np dot mean heights and the standard deviation height equals to NP dot standard deviation. And here also you need to pass the heights. Now what we have to calculate? We have to calculate G scores. As I said, how many standard deviations each height is from the mean. Okay, that's what it calculates. Now G scores, let us declare a variable and the formula. So what I'm doing, X minus mean underscore height divided by standard deviation of height for X in heights. I'm using here list comprehension. Now, so now I have to do print the mean standard deviation and G scores. So print mean height mean underscore height and print standard deviation. This is distributive underscore height. So G score finally, which is calculated from the formula. So G underscore scores. Okay, so in this example, the mean and standard deviation of the heights are calculated and G scores are computed to determine how far each height is from the mean in terms of standard deviations. Okay, so let us run this code. So standard deviation is there and G scores are this one. Okay. So this is the example of G score calculation for a normal distribution. And we have also seen calculating and visualizing normal distribution. Okay, so in this video, we have discussed about what is normal distribution, when why it is used, and we have learned few examples of normal distribution, and we have calculated and visualized the normal distribution, and we have calculated the G-score calculation for a normal distribution. Thank you, and you can watch further videos, upcoming videos. Please like, subscribe, and share the videos. Thank you.